Good morning, students. So once again I continue with 2019 EE paper, and the problem is stated as follows. A zero point 0.1 microfarad capacitor charged to 100 volts is discharged through a 1 kilo ohm resistor. The time in millisecond required for the voltage across the capacitor to drop to 1 volt is dash. Now, my sincere advice to students is to study DC transients. So DC transients is studied under three headings: transients in RL circuits, transients in RC circuit, and transients in RLC circuits. So here in the examination there is no time for you to derive the expression. So you have to remember the expression. So discharge of a capacitor equation has to be very well remembered. So it is DC transients. DC transients. The chapter is DC transients. Transients means disturbance, as you know. Now this is the capacitor equation. In the exponential fashion it falls. In the exponential form it falls to 0. So this is voltage across the capacitor plotted against time t. And the equation is, if it is initially charged to E volts, then voltage at any instant of time equals e power minus t by RC, where RC is called as time constant, resistance value multiplied by capacitance. Vt means voltage at any instant of time. For example, here, this is V, this is T, this is T, this is V. Now in this problem, capacitor value is, you have to very well remember this expression. Now capacitor C equals 0.1 microfarad. Then it is charged, it is discharged through 1 kilo ohms and it is charged to 100 volts. And it is through resistance of 1000 ohms. 1000 ohms. It is like this. Charge to this is discharge. Discharge equation. Discharge current. R is 1000. What is the time required to fall to 1 volt? So 1 volt. So from 100 volts to 1 volt. 100 volts to 1 volts. Larger the resistance in the circuit, longer is the time taken to discharge. So discharge process is delayed due to high value of resistance, as you all know. Now in this expression, if you write the expression, now Vt is equal to 100 e power minus t by RC. RC means 1000 into 0.1 into 10 to the power of 6 into 10 to the power of 6. Now 1 volt, Vt is 1 volt. So 1 volt is equal to 100, 1 volt equals 100 e power minus T1. I will call this as T1. T1. Simplify. If you simplify, into 10 to the power of 4 into 10 to the power of 4, take logarithms on both sides. ln now 1 is equal to 100 e power minus one thing. Before taking logarithms, further simplify. E power T1 into 10 to the power of 4 is equal to E1 into 10 to the power of 4 is equal to 100. Therefore, taking logarithms on both sides, natural logarithms on both sides, we get T1 into 10 to the power of 4 is equal to ln 100. Therefore, T1 is equal to ln 100 by 4 zeros. ln 100 by 4 zeros. 3, 3, 3, 3. Now I will calculate. Ln 100 equals 4.61. 4.61 divided by 10,000. That is, we have to express the answer in milliseconds. Therefore, 4.61 by 10 into 10 to the power of 10 into 10 to the power of minus 3. That is 0.461 millisecond. The answer is 0.461 millisecond. Now, once again, I want to bring to students notice. First of all, they have to very well remember the discharge of a capacitor equation. That is, V is equal to E to the power of minus T by RC. And then you have to apply this formula and you have to find. So, it takes capacitor to discharge to 1 volt in 0.461 milliseconds. Thank you.